Lecture is entitled Quadratic Equations in Vertex Form. So today we're going to be looking at quadratic equations in vertex form. But let's start off. I want to go a little bit of background about where this vertex form comes from. Where does it come from? Well, it comes from what's called transformations. Transformations. And what all transformations do is change the position of a graph. They change the position of a graph. So, how do we change the position of a graph? Well, let's say we have a basic graph of a circle. We're going to use a circle because it is the best way to explain how this works, is to use a circle, because a circle is familiar to everyone. So this equation is a circle with radius r. And I didn't draw a beautiful circle, but close enough. Now, if I want to move this circle, we can shift it horizontally, or we can shift it vertically. Later in higher math, you can learn that you can rotate. Rotating a circle is kind of silly, but you can rotate graphs as well using an advanced transformation. But we're going to keep these simple. We're going to just shift horizontally and shift vertically. You can also reflect it over the y-axis, which you wouldn't do with the circle because it would be the same, because the circle is symmetrical. But let's just talk about shifting horizontally and shifting vertically. Okay, so to shift horizontally, a units to the right. In the equation, we replace x with x minus a. We replace x with x minus a. So let's say that I want to move this circle 3 units to the right. 3 units to the right. I replace x with x minus 3. So we're going to replace x with x minus 3. And the equation would look like this. It'd be y squared plus x minus 3 squared equals r squared, where r is just the radius of the circle. It can be any number. Okay, so this would shift it 3 units to the right, so that means we would have a circle of radius r. The center would be 3 units to the right. 1, 2, 3. And let's just say this is, well, I just drew a terrible circle, but okay. There we go. So their circle would be over here with the center 3 units to the right. If we want to go to the left, we replace x with x plus 3. Okay, so to go to the left, we do the opposite of subtract, which is add. So to shift 3 units left, we replace x with x plus 3. Okay. So, we know how to shift horizontally. What about vertically? Well, you do the same thing. The only difference is we replace y with y minus b to go 3 units up, and we replace y with y plus b to go 3 units down. Now this doesn't work just for circles, it works for any kind of equation in y and x. Okay? So this is a transformation. So let's look at another example of a transformation here. Let's say we have the circle y plus 3 squared plus x minus 4 squared is equal to 16. Okay. And we should note that 16 is 4 squared, so the radius of our circle is going to be 4. Where is it going to be centered? It's going to be centered at the point, well, this is negative 3, right? Because it's y minus negative 3, which would be plus 3, so it's going to be 3 units down. So let me just kind of draw a little graph here. We'll just pretend we're going to scale it. So we'll have, we need at least 3 units down for our circle. And it's going to be 4 units to the right because that's shifted to the right. So it's going to be centered right here. And it's going to have a radius of 4. So we could say that it's probably going to look something like this. Okay. Where this radius is the square root of 16 or 4. Okay. So that's a transformation. Well, how does that affect our quadratic equation in vertex form? Well, that's exactly what it does. So let's look at our basic quadratic equation. The most basic quadratic equation we can think of, and that's going to be y equals ax squared. Okay. Y equals ax squared, where a is a number I'm about to discuss. So this is just, we'll just say this is your basic y equals ax squared. What I want to point out about this is not so much how much it stretches, but where the vertex is. It's at 0, 0. The vertex is the center of the parabola. It is the axis of symmetry. In other words, I could fold this in half. It splits it right down the middle. The vertex will split the parabola right down the middle. So the axis of symmetry is the line x equals 0, and the vertex is at 0, 0. Okay. So what does this a contribute to this equation? Okay, well, if a is positive, the vertex, the parabola, the parabola is what we call concave up. It faces upward. Okay, so if a is greater than 0, which means if a is positive, the parabola is concave up. If a is less than 0 or negative, the parabola is concave down. Okay. Now, a also controls the stretching of the parabola, the stretching of the parabola. So if a is very big, it's going to go up very rapidly. So this would be an example of a very large a. And if a is very small, let's say a is a fraction like 1/2 or 1/3 or 1/6, it's going to be very wide. So the smaller a is in size, not in sign, in size, the more flatter it's going to be. Okay. So, where do we get this transformation? Well, let's just say we have a vertex h comma k. So if I want to move the vertex, all I'm doing, a and x squared, all this stuff is going to stay the same. The only difference is I'm doing a transformation to the graph. So if I want to move the vertex h units to the right or to the left, I'm going to replace x with h. So we'll have this part of the equation will be a times x minus h squared. And let's say I want to move it up or down, then I want to replace y with y minus k. So this is the standard format of the graph. And some people also, if you add k to both sides, you solve for y, you can also see it in this format. Y equals a times x minus h squared plus k. Okay, so we're going to do 2 examples here. One of them is going to be easy, and one of them is going to be not easy. And both of these examples are going to involve completing the square. So if you don't know how to complete the square, then you need to review that before we move on to this. Okay, so let's look at an example. We're going to graph, and I'm going to use the calculator to graph, but I really want to describe the graph. Graph, find the vertex and the axis of symmetry Okay, so we're going to graph, find the vertex, and find the axis of symmetry of the parabola y is equal to x squared plus 4x minus 7. Y equals x squared plus 4x minus 7. Okay, this is not in standard form. Okay, so we need to do what's called complete the square. So I'm going to write the formula down here. Y equals x squared plus 4x, but I'm going to leave a little bit of room so I can complete the square, and I'm going to put this minus 7 out here. Okay, so to complete the square, if you don't recall, you take half of this number and square it. Half of this number squared, okay, half of this number is 2. 2 squared is 4, so I'm going to add 4 to this. But if I add 4 here, I need to subtract 4 over here. I need to subtract 4 over there. So now, what does that tell us? It tells us that this is factorable into x. What did we square? 2. We squared positive 2, so this becomes x plus what we squared, and you can FOIL it out. X times x is x squared. X times 2 is 2x, doubled is 4x, and 2 squared is 4. So these two are the same, and negative 7 minus 4 is negative 11. So that now tells us that we have a vertex at the point negative 2, negative 11. Negative 2, negative 11. And the axis of symmetry is going to be the line x equals negative 2. Okay, well, let's just say we needed to graph a few points. Okay, let's graph a few points. We already know at negative 2, y is 11. Why do I know that? Because it's given right here with the vertex, right? So let's go up or down 1. Let's go to negative 1. If we go negative 1 on one side, that means that negative 3, these two are going to be the same because we're symmetrical. We're on either side of negative 2 by 1 unit. So let's plug in negative 1. Negative 1 plus 2 is negative 1. Negative 1 squared is 1. 1 minus 11 is negative 10. So there's 2 points. And then you can kind of see the shape and move on from there. Some teachers ask for more than 1 point. I'm not going to stress the fact of graphing here. But I do want to show you that this is true on the calculator. So here's my graphic calculator, and I'm going to have to zoom out some because so we're going to graph this function, and it was x squared plus 4x minus 7, and you can see that this only goes down to about what, 1, 2, 3, 4, 5, 6, 7. So let me zoom out here. Zoom out. Okay. The only problem is when you zoom out, you kind of lose your scale. But the bottom here is 14, so you can kind of see that that's negative 11 right here. And then definitely the x-coordinate is negative 2. So this is the graph of y equals x squared plus 4x minus 7. All right, I said I was going to do one easy one and one hard one. I'm going to do a hard one. And what makes this one hard is that a is not going to be 1 on this example. And completing the square when a is not 1 is not hard. It's just really easy to make a big mistake. So what we're going to graph here now is y is equal to negative 2x squared minus 4x plus 3. Okay, we're going to graph that. Find the vertex. We're going to find the vertex, and we're going to find the axis of symmetry of this graph right here. Okay, so we can see that it's going to be concave down because a is negative. All right, so when we complete the square on this, and we do need to complete the square on this, we're going to factor a negative 2 out of these first 2 terms. So what we're going to have is negative 2 times x squared minus 2x, and then I'm going to put this plus 3 out here. Okay. So notice that I factored a 2 out. If I multiply this back, I get negative 2. Oh, I didn't factor negative 2. This needs to be a plus. Okay. So now when we factor this out, we get negative 2 times x squared is negative 2x squared, and negative 2 times negative 2x is negative 4x squared. Only these first two terms. Leave the 3 alone. Okay? So we're going to complete the square, and this is the easiest square to complete because half of 2 is 1, and 1 squared is 1. And here's the mistake everybody makes. I added 1 here, so I'm going to take away 1 here. That's wrong because I didn't just add 1. I added negative 2 times 1, which is negative 2. So I really added negative 2, so I need to add 2 to make that back. Okay? That's tricky. Okay? Just be careful what you add. Remember, when you put this square here, you have to multiply by what's out here and then do the opposite over here so that it matches. So now this is going to be negative 2 times x. What did we square? We squared positive 1. So x plus 1 squared, and 3 plus 2 is 5. Okay, so according to this now, we have a parabola with a vertex, the vertex, and I'm not going to plot points, I'm just going to show you on the calculator. The vertex is at negative 1, 5, because this is a plus. So that means the axis of symmetry is a line x equals negative 1. So that's where it's going to fold right down the middle. All right, so are you ready to see if I'm how magical this is going to be? All right, let's hope, cross your fingers, maybe I could have made a mistake, you know, but I don't think I did. All right, here we go. It's going to be negative 2x squared minus 4x plus 3. And when I do this, the vertex is going to be at negative 1, 5. So it's going to be up off the screen here. So let's see. Oh. Negative 1, 5. So 1, 2, 3, 4, 5. Negative 1. There's the vertex, just like we planned it to be right here. And it is concave down. And that is how you manipulate these vertex forms of fractions. And I appreciate your video. I appreciate you watching the video. If you liked it, throw me a thumbs up, subscribe for future math videos, and we'll see you soon, my friends. Thank you for watching.